In this video, we're going to take a look and see if we can determine whether or not a data value is unusual. So the standard deviation, it does give us a way to determine whether a data value is unusual. The way that we can determine if it's unusual is we can really try to find out, is a particular data value more than 2 standard deviations away from the mean? And so our smallest data value that we would still consider to be usual is whatever the mean is minus 2 times the standard deviation. And our maximum usual value is the mean plus 2 times the standard deviation. So anything that's more than 2 standard deviations below the mean, that's unusual. Anything that's more than 2 standard deviations above the mean is unusual. Anything that is between 2 standard deviations below and 2 standard deviations above, those values would be considered usual. They're not far away from this measure of center, the mean. They're within 2 standard deviations, so they are usual. So in our last couple of videos, we had taken looks at a data set dealing with Kansas City Chiefs, and we want to know here what is the minimum and maximum usual difference in scores for the Chiefs based on the previous sample. Right? So in that previous sample, we knew the mean to be 18. We calculated the standard deviation to be 7.79. So we're going to make use of those two things. Our minimum usual value is going to be the mean minus 2 times the standard deviation. Notationally, this is x bar minus 2s. And so it's 18 minus 2 times 7.79. That gives us 2.42 points. So if there was a difference of 2.42 points, we would consider that usual. Anything smaller than that, we would consider unusual. For the maximum usual value, we take our mean plus 2 times the standard deviation. Or notationally, it's x bar plus 2s, which in this case is 18 plus 2 times 7.79. Which gives us 33.58. So anything above 33.58 points we would consider unusual, but at 33.58 that would be considered usual. This is a football game. You don't have fractions of points, and so in the truest sense, that would be impossible. So 33.58 as a difference would be impossible. But here, that's kind of where we make that cutoff. So 33 is still usual. 34 is unusual. 2 is unusual. 3 is usual. A crude approximation for the standard deviation. So if you wanted to approximate a standard deviation, you don't want to go through all of the work. One approximation that you could take is you can take the range and divide it by 4. So we have this method where we found minimum and maximum usual values. It seems strange to talk about this crude approximation for the standard deviation with this. There's a reason why I talk about it here. Up here, this method that we found to determine unusual, this is called the range rule of thumb. And so the range rule of thumb to determine usual and unusual values, this is what we did. This method, this crude method for approximating the standard deviation, also called the range rule of thumb. That's a little bit annoying. I guess range rule. So that's a range rule for standard deviation. So be aware of that. You might need to use context to decide what range rule am I dealing with. If you're trying to determine usual or unusual, you're talking about this range rule of thumb if it's more than 2 standard deviations away from the mean. If you're just trying to get an approximation for a standard deviation and it says use the range rule, then you're going to just take the range and divide that by 4. If I wanted to approximate the standard deviation for this data set, I could take the 21 and divide that by 4. 21 divided by 4 is like 5.25. That's a crude approximation for the standard deviation. It underestimates the standard deviation because we found the actual one there. All right. There's one other thing I want to talk about here. We won't go through this whole process. But if we have a frequency distribution and we wanted to find that, the standard deviation given that frequency distribution, this is the formula that we would use. We would take the square root of all of that mess, which is really, really ugly. It's really time-consuming. Here is a step-by-step discussion of those steps. Feels like about 11 steps. You might be able to summarize that a little bit nicer. However, when you have something like this where the process is the same, these are things that make a lot of sense to do using technology. And so I would use something like Microsoft Excel to calculate a mean given a frequency distribution. So we're going to run into a lot of ugly calculations in this. All right, we will see you next time. Have a good day.